actions potential arrives at the end of a motor neuron. This action potential is developed in the brain and causes the release of the neutron transmitter, ACH. ACH is released. Is the neurotransmitter stored in the sympathetic vessel that crosses the sympathetic cleft and binds with ACH receptors. ACH binds to receptors on a monitor end plate. Receptors in the monitor end plate of the cilium of the muscle cells receive ACH and causes the permanently of the memory to the change. Permanently, sarcomere changes, Na rushes in, and action potential is produced. Sodium is an ion that changes the charge in sarcomere and passes the action potential into the TP. Okay, muscle actions potential sweeps into the T-tubules. T-tubules extend to the inside of the muscle cell and end up next to the ends of the sarcoplastic reticulum, where calcium ions are stored. Release of Ca from the sarcoplasma something, and then something else becomes permeable at the C ions, and the Ca ions flow out of the sarcoplasmic reticulum, or the actin protons live with trypsophones. Oh, I can't do this. This is so hard.
You're doing so good.
Okay, keep going. Calcium ions binds to trophon. Ca ions bind to whatever that word is. Troponin, and causes the troponin to change shape, causing troponosins to change position. Yes, it's on. Then troponosins changes shape and exposes binding sites of the action ison proteins. Binding sites that were covered by trophins because available for binding of mycin when calcium ions bind to the trophon proteins and change its shape. You think this one's it? Nope, it's right here still. Mycin heads crosses bridge and binds to ATCN. ATP released from mycin. Crossing bridges of mycin globular heads is formed to the acin binding sites. And ATP that was attached to the mycin heads are released, making room for the ADP. Mycin heads provide pulling actions. No.